Let's graph the solution region of a system of linear inequalities. Number 1. Y is greater than negative 2 over 3x minus 1, and y is less than or equal to positive 3 over 4x minus 4. Step 1. Convert the linear inequalities to slope-intercept form if needed. Both of these linear inequalities are in slope-intercept form already. Step 2. Graph the first linear inequality. We begin by plotting the y-intercept point, negative 1, and then follow the slope movement to find a few more points. Down 2 and 3 to the right. Down 2, 3 to the right, down 2, 3 to the right. We now know where the boundary line pattern will be, and the boundary line type that we will use is a dashed line. Y is greater than means we use a dashed line. The solution region for this first linear inequality is going to be shaded above the boundary line because the inequality is y is greater than, and y is greater than solution regions are shaded above the boundary line. This completes the graph of the first linear inequality. Step 3. Graph the second linear inequality. We plot a point, negative 4, for the y-intercept. We follow the slope movement of up 3 and 4 to the right, up 3, 4 to the right, up 3, 4 to the right. Our boundary line will be a solid line this time because it is y is less than or equal to, and the solution side for the second linear inequality is going to be below the boundary line because it is a y is less than or equal to, y is less than inequalities shade below the boundary line. Step 4. Plot two solution ordered pairs that represent the solution region of the system of linear inequalities. I selected positive 8, negative 3, and positive 9, positive 1. Positive 8, negative 3, and positive 9, positive 1 are two solutions that represent the solution region of the system of linear inequalities. How did we graph the solution of linear inequalities? To graph the system of linear inequalities, first we needed to make sure that the linear inequalities were in slope-intercept form, and then we graph each individual linear inequality, the first one and the second one, and then we interpret the solution region of the system by looking for the overlap of the two inequality graphs. You are now ready to graph the solution region of the system of linear inequalities in problem number 2.